Okay, so this video is going to focus on the very basics of naming organic compounds and structures that pretty much just have single, double, and triple bonds, as well as things that go into rings. So before we talk about any of that stuff, remember, when you have one carbon connected to another, we typically draw things like this, right? And let's count those carbons in this case. That would be 1, 2, 3, 4, 5 carbons, right? Okay. Now if I put in a double bond right there, that would be 1, 2, 3, 4, 5 carbons still, but that's what a double bond looks like. Okay? We'll get to a triple bond in a minute. So when we're naming things with single bonds, we tend to have an ending to them that just ends in A-N-E. Okay? So A-N-E means single bonds. Involving carbon, obviously. We can use these prefixes that you see up here to tell people how many carbons are bound together in a chain, or just in a line, if you want to consider it that way. And you put this A and E at the end to say, hey, everything's special or a single bond. So if you have something that's like methane, that would really be a dot, but we tend to write CH4 for this one because a dot doesn't show up very well. Okay. Ethane would just be 2 carbons connected to each other. Propane would be 1, 2, 3 carbons connected to each other. Butane would be 1, 2, 3, 4. Pentane is 1, 2, 3, 4, 5. Hexane is 1, 2, 3, 4, 5, 6. Heptane is 1, 2, 3, 4, 5, 6, 7. Octane would be 1, 2, 3, 4, 5, 6, 7, 8. Nonane is, that's right, it's called nonane. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And decane would be 10 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I highly encourage you, once you write these out, to go back and count. I still make mistakes on this all the time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how I do that? Make sure that you're counting the two ends, unless there's another atom that's written in there, okay? So we can name alkanes simply by putting this prefix on there and ending the word in ane. You could also write this as carbon, like C2H6. It's the same thing. If I were to write ethane in another way, remember from last time, we could also write it like this. That's just a long version of what I'm writing up here, these 2 carbons here. Or CH3, CH3. Those are all ways to write ethane. Here's where things get a little bit more complicated and fun though. The same way that we could have single bonds in a line, we could have double bonds. Now, usually you see a double bond, or maybe more than that, and there's usually next to a single bond right there. So here we have 1, 2, 3 carbons that are joined together. These two share a single bond, and this shares a double bond. So this is known as propene. So a double bond ends in the term ene. Okay. So where did I get the prop from? Remember up here? That means 3 carbons. So there's prop and then ene down here. Thing is that as these examples get bigger, you have to tell people where a given double bond is located. So, like here in this example, I have 2-hexene. I can either choose to number that from this side, 1, 2, 3, 4, and then my double bond would be between my 4 and my 5. And given that we read from left to right, that tends to be what you think you need to do, right? Well, if I number this from the other side, I get to that double bond faster. And the way that nomenclature goes with organic chemistry, you want to use the lowest number possible. And so this we label 2 because the double bond is between the second and the third carbon. So the 2 is given because it's the lowest number between 2 and 3. And so that double bond is assumed to be between carbon 2 and carbon 3. I get my hex from the fact that there's 1, 2, 3, 4, 5, 6 carbons there. And I get my ene from the fact that there's a double bond right there. Okay? So that would be 2 hex ene. In contrast, just to show you all this as well, this would be 3 hex ene. So, and it doesn't matter which direction you count from. 1, 2, 3, that double bond's between the third and the fourth, or 1, 2, 3, that double bond would be between the third and the fourth carbon in that chain. Oh, sorry, I didn't even realize that's what I had down here. These two compounds actually have different properties. So they're going to behave differently. They may boil at different temperatures. They may have a lot of things in common, and they may have a lot of things that are not in common. So you can't sort of categorize those together in the same exact name, and you have to tell people what the difference is between those two. So that's the reason why we go through the numbering of things. Now, if y'all are, remember, I did this in class. I'm sure you've seen this joke before. I'm a-dying. Okay, so that's a little joke about this chemistry, because there are 2 double bonds in the same little guy here. So 2 double bonds means a-dying. Okay, you end with A-D-I-E-N-E at the end of the word. And in this case, you have to tell people where both of those double bonds are located. So here we go. In this case, we have 1, 2, 3, 4, 5 carbons. I can count from this side, which would give me a 2, 3, 4 in my numbering. And that is higher than if I start from this side. So I want to start from this side and go 1, 2, 3, 4, 5. So that's the reason why I go with this numbering system, is because that gets me to the lowest number for that double bond right there. Okay? And for overall, for that matter as well. So you still have to tell people where the double bonds are located in both of them. So there's a comma between those two. So it's 1, 3 dash. Pentadiene. Okay. Where did I get the pent from? Remember? That's right here. Okay. Next comes alkynes. Alkynes can do all kinds of stuff, right? Well, okay, so alkynes have a triple bond in them. And these can be a little bit deceptively confusing. So let me remind you, when you have a triple bond between 2 carbons, let's say we looked at something like this. The molecular geometry around this carbon involves 2 atoms that are attached to it, and that's it. Well, the easiest way for those 2 atoms to get as far apart away from each other as possible is to simply be a line. And so, when you see these written on paper, this actually means a carbon is here, 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 and here. Because these 2 carbons have a triple bond, but that means the other atoms that are attached to them are flat and are like in a line out there. So be careful when you count these that you really include all of the carbons that are there. That's the reason why this is a hex of a molecule, because it has 1, 2, 3, 4, 5, 6 different carbons. Okay. Now, when you have a triple bond, instead of ending the word in an A and E, ane, or an E and E, een, so enes are for double bonds, you end the word with ine, Y-N-E. Okay. And just like with the hexenes or with the alkenes period, you have to tell people where that triple bond is located. If I started to count from this number, it'd be 1, 2, 3, 4 hexyne. But if I start from this end of the molecule, I go 1, 2, and that's between the second and third carbon. Therefore, that would be 2 hexyne. Okay. And next, we can cyclize these guys. All of the big differences between cycles and lines is you tend to write, or you write a cyclo at the beginning. Okay. Now, it is true that, again, you have to tell people where the double bond is in something like this. But what I didn't say earlier, if you have something like this, that would be 1-butene. Sometimes we just don't even write that 1 because it's understood, just like you don't say 1x, you just mean x in math. So here, cyclopentene means that the double bond is between the first and the second carbon, and it doesn't matter if you number it this way or if you number it this way. It's the same thing, so it doesn't really matter. And you can get a little bit more complicated when you have things like you see here, because now we have to figure out how to count this in the most logical way. So it would be 1, 2, 3, 4 in that direction. Now let's say that I wanted to start again at a different point. Let's say I started here and said 1, 2, 3, 4, 5. Do you see how that would be a 1,4 cyclopentadiene? Well, that's not as desirable because this is a higher number than what you have over here, and so this is actually the preferred nomenclature. Thank you very much. I'll have another one in just a minute on naming other types of functional groups.